Hello, my name is Leonardo Campos. I'm from Brazil and I study at Federal University of Minas Gerais with mineral technology. Today, I'm talking about my research named Evaluation of the Action of Different Collectors on the Selectivity of Phosphate or Flotation. This paper was developed with me and Roberto Gallery, Itamar Daniel Delben, and Paulo Roberto Gomes Brandão. The principal natural mineral source of phosphorus is apatite. Phosphorus is used especially as a micronutrient fertilizer in agriculture. In Brazil, phosphate rocks are essentially of igneous origin. Although Brazil is a phosphate producer, it is not self-sufficient and needs to import a large amount of material, making phosphate a critical and strategic input for the country. A variety of carboxylic acid reagents are used in the flotation of phosphate ores. The commercial reagents are composed by a mix of different carboxylic acids, from short chains with 5 carbons to long chains with 18 carbons, and the proportion of each oil influence on flotation. The aim of this paper is evaluating the effect of the composition of different types of fatty acid brands on the floatability of a Brazilian phosphate ore. The ore used on this paper are a typical Brazilian phosphate ore from Catalão in the state of Goiás, Brazil, illustrated on these photos on the right. Three distinct brands of oil composed of a fatty acids of different origins and composition, denominated as AC1, AC2, and AC3, were tested as apatite collectors. Cornstarch are used as a gang depressor, and the commercial fluoride are used as a fluoride. For characterize the phosphate ore, it was realized the following tests. First, the size distribution. After, was realized the X-ray diffractometry and X-ray fluorescence for describing how it's the composition of the ore. A sample of the initial feed and the cleaner flotation products was mounted in the polished sections and submitted to microanalysis with scanning electron microscopy. The digital images resulting from the SEM analysis were further processed in the MLA, mineral liberation analysis. All the reagents are characterized by the following tests: the degree and the extension of the saponification, the infrared spectrometry, the gas chromatographic, and saponification index. Bench scale flotation tests were realized. The flotation cell used was the Denver brand, model McDermott D12. The tests were performed in the two stages, rougher and cleaner. A dose of 500 grams by ton of cornstarch was initially added as a gang depressor and conditioning by 5 minutes. After the cornstarch conditioning, the select collector was added at a dosage of 312 grams by ton and conditioning by 2 minutes. A commercial fluoride was also used at a dosage of 30 grams by ton and conditioning for 30 seconds. Sodium hydroxide and hydrochloric acid were used to adjust the pH to 9.5. There was no addition of reagents in the cleaner flotation stage and conditioning time of 2 minutes. The particle size distribution is within the ideal flotation concentration range, with pH equivalent to 150 micrometers and only 20% of the mass below 38 micrometers. The XRD analysis showed that fluorapatite is the main phosphor mineral present in the ore, followed by the quartz and other minerals. Table below shows the XRF results, which indicate that the sample presents 25% of P2O5. The photo on the right presents the digital image of the ore sample analysis with SM and MLA. The table below shows a composition calculated by MLA system, corroborating the XRD and XRF results. Table below presents the results of gas chromatography analysis. The following table shows the results of the test of Si and Sd for three collectors analyzed. The AC3 reagents had lower Si and Sd values than the other two reagents. This may indicate that AC3 has a higher proportion of non-saponifiable components. Figure on the right shows the infrared spectra. The IR spectra shows similarities between AC1 and AC2 reagents over the entire spectrum except at 1740 band, which agrees with Si and Sd results. This band indicates the presence of triacylglycerol and other esters. AC1 had a small absorption at this band, and AC2 didn't at this band. The AC3 spectra was also analyzed after being submitted the saponification, which is present on the picture below. The fatty acid soap was identified by the absence of the 1710 band and the band displacement from 1547 to 1558 in the saponified products. This justifies the hypothesis that the displacement occurred exclusively because of the presence of a complex, and not because of different structures present in AC3 reagents. The presence of esters at 1740 band of the saponifiable reagents is still very significant, which was expected, considering the low SD value obtained for these reagents. Metric curving with AC1 and AC2 as a collector were very similar, but however, AC2 was more selective than AC1. This can be explained by the higher proportion of oleic acid and the lower proportion of linoleic acid and linolenic acid in AC2. Considering the overall results, the reagent with the best performance was AC3. The better performance of AC3 collectors can be explained by the large amount of non-saponified material identified by the infrared spectra and by its lower SD. These factors help to decrease repulsion between the carboxylate ions, forming the ionomolecular complexes, and thus increase the apatite collector power. The mineralogical quantification shows that AC3 concentrate has a higher proportion of contaminants, represented by iron ore, minerals, and quartz. These contaminants are not present in the cleaner concentrates obtained using by AC1 and AC2 collectors. In conclusion, we conclude that AC1 and AC2 had similar chemical compositions, and AC2 has a higher amount of oleic acid and lower amounts of linoleic acid and linolenic acid. AC2 had better flotation performances than AC1. And the composition of AC3 had a marked difference with AC1 and AC2. This means indicate that the reagents presented in natura part was partially saponified. The band scale flotation results obtained using AC3 as a collector were quite superior to those at AC1 and AC2. AC3 has a higher power of collection. How about the presence of esters on composition? And these esters reduce the repulsion of the carboxylate ions. But what's the link with this paper and the purpose with this congress? The sustainability. AC3 has a better performance on flotation, on phosphate flotation, and it indicates that reduce the P2O5 grade on tailings and reduce the amount of material that will be direct to tailing dams. In Brazil, especially, tailing dams are a critical problem at now because the accidents in Mariana and Brumadinho, which destroyed the environment and killed hundreds of people. And this is my acknowledgments and my reference. Thank you for everybody.